I like to think of innovative technologies as falling into two buckets. There's one bucket where things are regularly being reinvented, where new solutions are being tried, tested, and proven out. In the other bucket, there are the projects that look at things from the first bucket and see what is and isn't working, see what's causing those things to be adopted, what's making it harder to use them, and how we can benefit devs in a more immediate sense. For one example of this, we can look at something like signals, which were pushed really hard in some older frameworks, but most notably, the new framework, Solid. And in a lot of ways, Solid is trying to be super, super innovative. Eventually, other frameworks, like even Angular, saw that innovation, saw the parts that would be the most useful to the average Angular dev, and took those things. Both of these frameworks are innovating, but they're doing it in very different ways. Solid is pioneering new solutions, and Angular is trying to take those solutions and make them useful to existing devs. Now think about the framework Astro. Your immediate thought is probably that it falls in that first bucket of doing things that are truly unique and innovative. And in some ways it is, but I don't think that's the goal of Astro. The reason I started using Astro was actually a quote that used to be on their homepage. I found that Astro was the first time that the existing tools I was used to from the JavaScript ecosystem, things that I would use with stuff like React, could be used well with a static site builder. So I wanted a static site, like a blog or a marketing site. I could take advantage of all the fun tools like, Tailwind that I was used to using in React and get the same benefits, but with a static site builder. Astro has obviously progressed a ton since then and is used for all sorts of awesome new things. But today, they drop one of my favorite updates to date, because this update takes one of my favorite new features from Next.js and makes it accessible to basically everybody, regardless of your infrastructure, which, to be clear, is not the case with the Next.js version. That new feature is being called Server Islands. I'm blown away with this feature. It's such a cool solution to getting the streamed responses benefits that we get from something like Next, while also letting you statically host your content. And all of those words might not mean much to you yet, but we're going to get to what they all mean as we go through this, because this is a really cool update. Before we get to this, we'll talk about Next. Before we get to Next, we're going to talk about islands. You might be curious what an island is. Let's say most of this content is static, but you want this Book Now button to be a mini React component that has all the fancy interactions you'd expect from React. Maybe you have one of those chat widgets in the corner that has all the fun behaviors you would expect from the little built-in intercom chats you can click and ask questions about the product. What if you didn't want all of those to be part of the exact same React code base that powers the whole site? What if I didn't want React code for this part on the left? I just wanted it for this button and maybe for that intercom thing in the bottom. What dynamic islands do is they let you have little islands of dynamic behaviors in your site. And when you use them with something like Astro, that means you can write the whole site as a static template using something like Astro syntax or even using React directly, but you only send the JavaScript to the client when you tell Astro to do it. Let me find it in their docs. Oh, look at that. Their docs even describe this more directly for us. An island refers to any interactive UI component on the page. So if the header is interactive, that could load some JavaScript and be included that way. But maybe the static sidebar, maybe the content is static as well, maybe the footer is static, but you have an image carousel, which is also interactive. So to make something an island, all you have to do is mount a component from React or Solid or whatever framework, and you specify client::load. Now that component is interactive on the page. It will actually send the JavaScript down. Let me go initialize an Astro project so I can actually show this. Include sample files, TypeScript, strict, yes, yes. Yeah, the Astro CLI is dope. Get those deps. Cool. And here we have the project. Git, commit, init. We have our initial commit. Let's add React quick, because it's pretty easy to do. Now we have React added. I'm just going to clear out some of the junk here to make the markup a little easier to read. And now we have this nice little blank page. It says, hi nerds. Let's make a React component. We'll do our favorite counter.tsx. Export function counter, const count. I have to import React. So now we have our counter. And if we want to use this, it's as simple as putting it in the code. So here, we're going to paste the counter. It's going to import. Theoretically, it should just work. And if we go here, we see count is 0. And wait, when I click it, it's not working. What's going on? This is where the concept of islands gets useful. By default, your components are only going to run on the server, be it in build or if you're hosting your Astro app as a web service on request. By default, when we were to run build, this would spit out HTML that includes this in the HTML with no JavaScript to actually run. So if you want this code to run, you don't want to just include this component because it looks nice. That's when you would specify something like client load. Hopefully you would spell client right. And now that it says client load, this will actually send the JavaScript to the client. And that is what an island is. It's a component that loads its JavaScript because you told it to. And what's cool here is I could have multiple of these in different places in the app, and none of them interfere with each other because they're all loading their JavaScript separately. That's what an island is. Instead of having one giant React app that runs the JavaScript for everything, an island is a little piece of your page, almost like a component, that loads its own JavaScript for its own needs. So most of your site can be static, and then just those dynamic parts can be dynamic. So that's the first thing we need to understand, because as you saw, these are server islands, not dynamic islands or client islands. These are server islands. And while it would be fun to dive straight there, I think a quick tangent to Next.js might be useful here. So partial pre-rendering is an awesome new feature in Next that is admittedly hard to set up on your infrastructure. Vercel even has had a lot of tough work in order to make this function because it's hard to do. In order to understand PPR, it's important to understand a little bit about content streaming. If you go to a website like, let me just initialize a Next app. I'm going to be writing a lot of code for this one, aren't I? Okay. I have a really basic example here. Export default function home. So this is the home page, all in React. Hopefully we all know basics of React. I have two elements in this main. I have the div for this is static, and then I have this slow, I'm going to rename this for slow page to slow component. So we have slow component, which has to wait for 4 seconds, and then it returns. So if I was to bun dev, this guy, you'll see the page is taking its time, 1, 2, 3, 4, however long. And then this is static, this is dynamic, and slow. That sucked. We had to wait the whole time. And if I go back to the network tab and we refresh this again, you'll see it's taking forever. It's just sitting in that pending state. And it took the whole 4 seconds to load. That sucks. If you have one element on your page that takes a while to render for any of many reasons, it takes way longer for that to actually run. So how do we prevent that? This is where one of the coolest new features of modern React stuff comes in. Streaming, specifically out of order streaming. So if we wrap this with suspense, so we're just wrapping the slow component in suspense. We could even add a fallback. Fallback equals, cool. I accidentally deleted the slow component when I did that. Cool. So we have the fallback with loading, and then slow component comes in. And if we reload this page, now it loads immediately with the loading there, and then the content comes in. If we go back and we look at this request, you'll see something interesting. I wish you'd let me zoom in more easily here. I lowered the time so it'd be easier to see this. You see that little green bit there? That's how long it took to get something back. And then everything after is what happened afterwards. So the green bit there is the server sending its first response, which is the content of the page. The blue bit is the stream. It's everything else that comes afterwards. So the cool feature in Next that I'm showing is that you can wrap certain parts in suspense, and now these won't block a response. Without this suspense boundary, React has to wait for this component to render before it knows what HTML to send the user. By putting suspense in, we're telling React, hey, by the way, you can skip this part for now, send a response to the user when it's ready, and then update that later on out of order, which means we can put this anywhere. I can put it above, I can put it below, I can put it in a different component. React doesn't care, and React will figure out once this is done resolving how to stream it to the user and put it in the right place on the page. That's so cool. The fact that we don't have to think about where it goes on the page, it just works within React, is one of those subtle miracles that isn't given enough credit, but it's awesome architecture, enables really cool things. But there was a catch. In order to get that first page, in order to get the thing that was initially responded with to the user, which would be the HTML that I have here, if I just open this there, skip all the JS stuff, where we have the main content, this is static, and then this loading div. In order to get this to the user, we had to run a server, which meant that we had to wait for a Lambda to spin up, deal with a cold start, process the request, generate the initial response, figure out what parts needed to be streamed in, and then send it to the user. That's a lot of steps to do before the user sees anything. And during that time, you're going to be staring at one of those ugly browser loading pages that might just be a blank white page. Ideally, if everything in this file is the same for all users all the time, we shouldn't need to wait for the server to spin it up and send this first chunk down. If this first response, if the part that's in green here at the beginning, if that green bit there is always the same for all users, why do we have to wait to send this part? Why can't we just cache that on a CDN? That's what partial pre-rendering is. Partial pre-rendering is identifying what outer shell and template, so to speak, of your site is common across all users. So that can be cached on a CDN, and then the rest of the dynamic content can be streamed in when it's ready. This is awesome because this means you don't have to load any JavaScript really at all. You don't have to wait for a server to spin up. You don't have to wait for anything. You just load the static shell the same way you would load a plog off a CDN. So you get that immediate instantaneous load time. And then the server can stream in the dynamic parts when they're ready. This is an awesome pattern, but it turns out it's pretty hard to implement because you need to have something that can grab both the CDN cached chunk and then send in the streamed stuff afterwards and handle that fast enough that you're not eating more performance issues. Vercel has this working on their infrastructure, but getting it working on your own isn't fun. It might be easier in the future, but right now it is hard to have a streamed response where the first chunk comes as quick as possible from a CDN and then the rest comes in later when the server is done generating it. That is difficult to do. Hopefully this is useful context as we dig into what Astro just released with their experimental server islands. I think I need Excalidraw. So if we have our server and we have our user, the way things used to work is the server would just send one response to the user. But with PPR and server-side rendering and all these fun things, it all gets more complicated. So instead of doing PPR first, we'll do streaming initially. So the way Next streaming works is the user requests to the server, "Hi, give me site." And then the server sends, after doing all of its work to generate the stuff, HTML shell. This is where it sends all the things that aren't suspended. And this will also include things like JS tags, like CSS, all of the sources and additional data the client might need. So it can start loading those things. It can load the font. It can load the CSS. It can load the JavaScript bundles. It can load all of those things while the server is continuing to do more work. So afterwards, the server sends another response, which is whatever was inside suspense. The interesting thing here is the server sends effectively multiple responses to the user. The first one it sends is that HTML shell, which is everything that's not wrapped in a suspense. And then everything that's in a suspense, it just slowly sends over. So it could do this once, it could do this 5 times, it could do it however much it needs. And if we go back to my code example, we could even do that. Let's change this slow component so that it takes in a number. Props number, I'll say time number. And we'll wait for props.time here. We'll pass one that's 500. We'll do one that's 1,000. And we'll do one that's 3,000. And I'll change this to say, and took props.time milliseconds. Cool. Nice. So now if we load the same page, you'll see this is dynamic took 500, this is dynamic took 1,000, and this is dynamic took 3,000. And if I start recording that again, you'll see all of these came through as updates as part of the stream. Next.js handling that for you and meaning that the user can get a response faster is awesome. So this is how Next.js streaming works. It sends whatever isn't suspended, and then it sends the things that were suspended after. How Next.js PPR works is a bit more complex. We no longer have just the server. Instead, we have what I'll call the edge. And the edge has 2 additional places that it is going to communicate with. It's going to communicate with the CDN and the server. So this time I'm going to use colored arrows to make things a little clearer. We're going to make the CDN blue and we're going to make the server red. So the first thing we did is we send to the edge, "Hi, give me site," as the user. So what we'll do there is we're going to forward that request over to the CDN. And the CDN is going to give us the same thing that our server would have given above here. So this HTML shell that would have been generated by the server is instead coming through the CDN so that it can come way faster. And while that is happening, we are spinning up the server. So at the same exact time this is happening, and I'll put that there to be clear, we also hit up the server and say, "Hey, server, start spinning up." Now the server doesn't know jack shit about this CDN. These two don't know about each other at all. So the first thing the server does is it sends the exact same chunk that the CDN sent. And then this first server request, which is the exact same content, gets killed because we already sent what was in this to the user. But then an important thing happens. A streamed update comes through. And the streamed update can operate against the cached page the same way we were doing before. And then that third cached response can come in as well. This diagram could be done much better, but the point isn't to make the most beautiful possible diagram, it's to showcase how this actually works. And then the server sends the streamed updates, and those make it to the user, and it behaves the same. So as you see, going from here to here is a bit complex because now you have to deal with a lot of different types of infrastructure in order to orchestrate all of this. You need to have an edge that's smart enough to hit a CDN and a server at the same time, send the CDN cached shell to the user, kill the first response from the server and drop it, and then forward these additional suspense changes to the user. So basically, how does the CDN get updated? That's just part of your build process. When you build your site, when you run next build or run CI, it will spit out these changes that go to the CDN. Because again, this requires the first chunk to be static and shared between all users. So if we go to the example in the Next docs, which I closed, on this fake e-commerce site, the logo will be the same for everybody. The search bar will be the same for everybody. The picture of the item and the description will be the same for everybody. But what's in your cart will be dynamic and the recommended will be dynamic. So the static shell that is the same for everybody, that's determined on build or on the first time somebody goes to the page, that can be thrown in the CDN, and then everything else gets streamed in afterwards. The thing I'm trying to showcase here is that this is slower because you don't get to see your site immediately because you have to wait for the server. The server takes more time than the CDN, period. So if your goal is to get the user to see something as quickly as possible, you need a CDN. But if I was to put the CDN in front here instead, the server never gets hit. And that doesn't work. That's why Vercel has created this complex infrastructure with an edge that goes between the CDN, the server, and the user in order to make sure all of these chunks get orchestrated to the right place at the right time. This is complex, and I'm not expecting everybody to follow this because this is not simple. And that's why we need to talk about how Astro does it, how Astro server islands work. First thing we have to do, delete this chunk in the middle edge. That is now gone. Now we have to move the CDN over and also delete all these arrows that are connecting to it. Because the way that Astro server islands work is a lot more similar to how sites worked traditionally in the past, where the user requests from a CDN and they get back that static shell. Then some interesting things happen. The user has to load whatever JavaScript is here, figure out that there are some holes in the DOM. So if we write this out as code, we have HTML, div, static stuff, div. Now we have div, we'll say needs content equals /something. If this is the content of the page, then what we've loaded now is this HTML with this div, and then this empty div that has this specifier in it that it needs content, and it needs it from /something. So here is where this gets interesting. We're going to grab our old server. We're going to delete all these arrows. Once the user has parsed the JS, loaded the HTML, and realized, oh, in order to fill this hole in the template, we need to get more data from the server. That's when another request is made, this time to the server. So this request would be going to, change this off of that syntax, /server, or /something is what I said. So they are now requesting from /something, and now the server can generate whatever element needs to go into this box. And then the server sends that. Well, let's say there's two of these, like I had in the example above. So you have something, I'll have div needs, I just realized my face is covering this, isn't it? Thank you guys for the heads up there. Cool. Sorry about that. Here's the HTML. Content equals /something else. So the server or the user can then immediately, once finished loading, request something and something else at the same time. I'm going to move the arrows accordingly. So they requested something and something else. And now, since there's two requests going on, the server can be a boring old server and just respond with these two responses whenever it's ready. This makes things a lot more simple. You can see why they would want to do this. So this is a really elegant solution where the server islands are a way to tag a given element and say, hey, this element needs more content from the server. This does have a cost though, which we'll get to in a bit. But first I want to try it and play with it because this is an awesome new feature. Mark your components with server:defer, and they'll now be rendered on the server at runtime independently from the rest of your page. You can now safely cache these pages at the edge and get great LCP, which is largest contentful paint scores. That's the great part, is you can take the static part and throw it in S3, throw it in a generic CDN, throw it anywhere the way you would with any traditional CDN and static site generator, and then the dynamic parts can be requested and fetched later on. So if I was to go back to the Astro demo here, we had this counter client load. Instead, we're going to make a new card. We'll call this slow card. Slow card, I don't care about this additional stuff. We'll leave the title in the body. I'm going to kill the link, but we're going to do time number. Pass time. We're going to kill the link tag. Cool. So I just created an arbitrary block now where in this component, we can pass it an amount of time that it will now block for. So obviously, if we were to generate this as a static page, this won't be included because it's going to take some amount of time. We want this to be dynamic. So now if we go back to the page and below the counter, we do a slow card. It's going to type error because we need a title equals this is slow, body is cool. And we have it wait a second. Cool. Do you see that took some time to load in? I'm curious how they did that in a way where the rest of the page loads. I think the default behavior now is streaming in Astro. That's the only way that would make sense. Interesting. Okay, so it is smart enough to just do that. Can I tell it to block? Is there no way for me to say, wait there? I'm very curious. I did not realize Astro just blindly did the equivalent of suspense whenever there's something that takes time. Very interesting. Fred, I will send you this VOD and you will hopefully fix more things for me. A bit annoying to demo, but the thing I wanted to showcase here is that this code here was put under a promise. So this card, this is slow, took a second to load, but it did that load during build, which means that it can't be dynamic. So let's say instead of it just showing that, we also render what time it is. So if I go back to slow card and we add here const current time equals cool. And here, I'm going to change what this renders. And in here, instead of the body, we're going to render the current time. We won't see any change here because I'm in preview mode. So I have to bun run builds and now bun run preview. And you'll see there that it's 5:52:46, even though I'm refreshing, because all of this content is saved as an HTML file. And if I was to go into dist, index.html, and I open this in a new thing so I can format it. So here's the HTML that's being sent from the server, which we know because it's being saved here. And in here, we have the welcome to Astro title. We have a bunch of inline CSS. We have the style for all the slot stuff. What we care about, we have the count is, and then this indication so that it can mount stuff in Astro world to take over once the JavaScript loads. Has these Astro Island elements that handle all of that as well. But we have in here, hard-coded as HTML, 5:52:46 p.m., which is the time that this was built. This will never change, even though the code that we wrote is dynamic, because in this project, we specified in the config here that we're outputting a static site. So now I'm going to delete that, and we're going to rerun the build. Bun run build, bun run preview. Same deal. Even with static removed, because Astro by default wants to generate a static site, it's still trying its best to. So it made a new index.html file with the same stuff going on inside of it. You can see that this is slow. You can see the hard-coded time here. What if we want it to be dynamic? Well, we can go change in the Astro config and make it so that the output mode is server. Now we're going to kill this and run build and preview again. I have to run build because I want to show the behavior difference, and it only shows it if you build and then preview. The Astro Vercel serverless adapter does not support the preview command. What does then? How do I preview this locally? I'm in pain. I had to switch adapters to be the node one so I can run it locally. And now I should be able to run it again. Cool. So now we're running Astro as a server. What does that mean? Well, if we look at dist, we no longer have that HTML file. In fact, there's no HTML files here at all. And if I was to go load the page, now it's going to do the streaming behavior where this gets streamed in. The catch is the initial page is coming from a server as well. So you won't get those super fast response times you get from a CDN because that initial response has to come from a server. In this case, that server is my computer, but that server has to be running, has to be reached by the user, told, hey, here's what I need, and then the server can generate the HTML on demand and send it to the user. So we have to eat all of the time it takes to reach the server, to spin up the server, to process what the user's looking for, to generate the response, and then send it to them. And if the server's far away enough, that sucks. But also, we get that streamed in response after. So the content of this div doesn't come in until after the page loads because the server can fill that in. This is working in this case literally identically to here. The streaming in Astro and the streaming in Next work exactly the same way. So all we have done here is this. But that means we're not getting the benefit of the CDN. Ideally, that first response comes from a CDN because it'll be much faster than waiting for Node to spin up a server and send a response. So how do we deal with that? How do we put a CDN in front? That's what the new feature is. That's what the server islands are introducing. So if I go back here and we look at how we actually introduce this, we're going to change the output mode to hybrid. And we're going to turn on the experimental server islands feature. And now we have the fun new feature, defer. Now, if we rerun the build, now if we look at the distribution, the client code has HTML again. So you can take this client directory and throw it on a CDN because we can load this page. In fact, I can even do that. If I yoink this, reveal in Finder, what's the easiest way to host a server from the current directory nowadays? It changes every time I ask, I swear. npx http server. So what I'm doing here is I'm just hosting the HTML file that came out. So if I copy this link, I go to the browser and paste it, the page loads, and the JavaScript even runs because, again, that's all part of that static client bundle. The client code has the index.html, and it has this JavaScript, including the JavaScript for the counter that we wrote, all bundled in the client-side stuff. But you'll also notice that this chunk here is missing, that we didn't get the HTML. I'm going to bring that back in a very interesting way. You'll see here that we're getting the error that it's requesting server island slow card and is not able to get that. The reason is because we're not hosting the server part. We only are hosting the client part right now. This is all static. I'm running no Astro code on the server right now. I am just hosting this client-side code as a generic CDN server. You can throw it in S3 wherever else, but we're just hosting the HTML, the SVG, and this JavaScript bundle. We're not running any server-side code. So I could go brute force that to run in here, but it's going to be much easier to instead go back here, run the preview command. And now if we localhost 4321 again, this is where things get fun. The HTML it sent in came in first, and I can prove that. We can go into the client code here, and I'll add some stuff here. Hi, via hacking the HTML. Oh, does it think that's part of the other element, so it's mad? That's got to be the case. Oh, because it's part of the island. Cool. If I remove that out of the island and put it above, here we have the hi via hacking the HTML, which again only works because the HTML client code doesn't get touched by Astro on the server. This is a static HTML file that could be served however the hell you choose, and then the other parts come in dynamically after. So the HTML loads, and you'll see if we look through this HTML file, there's a lot of shit going on. But what we care about in here, it's the slow card here. So we have this server island start markup, the script that identifies which island we're loading data for. It specifies the component ID, specifies the export, specifies the query selector to get to this element. It specifies the data that we're passing as props, which I showed you before is all the data that I put here. So all of this is being sent to the server almost like HTMX style, like posting with this stuff saying, hey, here are the props for the element that I want. And then and only then does the server get a request, spin up, and the server's request isn't load the page like it is with Next. The server's request is, I need this specific component's HTML. So when the page loads, it parses the JavaScript and it realizes, oh, this element is missing. I need this specific element's HTML. Hey, server, here are the props. Here's the element. Can I have the actual HTML code, please? And then we literally post with this JSON to server island /slow card for the specific component we're trying to get. We literally are hitting up server island /name of component HTML. I can prove that by console logging what it puts here. Console.log. Again, this code doesn't get run by the server here. This is all client side. Here is what the server sent. HTML. Cool. And if I open up console and reload this, we'll see here is what the server sent. It sent an li element with class link card, data Astro, yada, yada, H2 with more Astro data. This is slow, P 6:05:18 p.m. And if I refresh, we'll get a different time because this is being dynamically generated by the server. So the way that this works, if we go back to my diagram, is the user loads some content from the CDN, an HTML file. They parse the HTML file, they parse the JavaScript in that file, and they realize, oh, I need these additional elements in order to finish this page load. Then it sends those things as a post request to the server with all of the content that it needs, so the props for those components. And then the server sends down as a response each of those individual HTML chunks. That's what server islands do. So there's an obvious benefit here. The obvious win is that anyone can host this if they already have the ability to host a website through a CDN, and they have the ability to put a Node.js server somewhere. This makes this very easy to adopt for existing developers in existing solutions without seeing any compromise on the quality of experience users have. The catch is that the server can't start doing anything until the client has loaded the JavaScript. The benefit of this flow, and the thing I was trying to highlight here, is that with Next.js PPR, when the user makes the request, you can immediately start both the server that needs to generate more responses as well as the CDN, which is responding immediately. So you get a best of both here, where the server can start responding, start spinning up and doing what it needs to as soon as the edge gets the request. But you don't have to wait for the server to start before you can send something. So we're able to start these both in parallel. What the Astro solution does is it defers that first bit, the server starting. It now takes longer for the server to start. The server has to wait until the client has loaded the JS and then pinged it with that post saying, hey, I need more data. So if the thing you're bottlenecked on is how long the server takes, that sucks now. It takes longer for that content to pop in. But we do have the big benefit, the hill I always die on, which is the quicker you can show the user something that isn't a blank white page, the better, because we get a CDN response immediately. So this is the checks and balances, the benefits and the negatives. As long as you're getting a CDN response to the user as fast as possible, it's going to feel really fast. I know that because that's how ping works. The vast majority of why ping feels fast is because we static cache every page and the data comes in after you've loaded the static page, after it's parsed to JavaScript, and then it makes a request to the server. So in most regards, it's slow. The actual time it takes to get that final response is slower because we have to wait for the user to fetch the page, load the JS, parse the JS, figure out what it needs, and then request the server. And then the server can start doing work. With the new Next PPR model, you can run those things in parallel, which has awesome benefits, but also, as we showed, is pretty complex infrastructure-wise. So if you're not willing to shake up your infrastructure to do this, but you really want to get a static response to the user as quick as possible without compromising on the ability to have things like the cart, the recommendations, all those types of things in like an e-commerce world come in dynamically, server islands are a really good compromise. I am hyped with what they've done here. It is a genuinely cool way of seeing the benefits as well as the problems that we're trying to solve in the next world, recognizing that the CDN response is really, really valuable, but generating dynamic responses within the page is also valuable. And we shouldn't have to do all of this by loading a dynamic island that fetches JSON and then renders on the client. There's no reason we shouldn't be able to have a page where most of the parts are static, and then those little additional personalized chunks come in a bit later. And that's what Astro has enabled here with server islands. It's actually very, very cool. And I am honestly planning on implementing this on my own stuff. A great example of what this would be good for would be something like a hit counter. If I wanted to have on my blog, which by the way, I do have a blog, I don't update it enough, so don't make fun of me for it. If I wanted to have a hit counter that tracked how often this page has been visited, I wouldn't want to have the server block you from seeing the page until that's done. And what's cool with this is that I can now have that one element, the hit counter, come in when it's done and then serve the rest of this through a static CDN. It's great. One additional benefit is since you're not running Next and all of its giant piles of JS, your LCP is a decent bit faster than it would be if you had to load all of Next, which is cool. There are definitely benefits here. PPR needs to block on this JS to load before paint. Yeah, that's fair. But also, to Next's credit, having to load a little bit of JavaScript in order to make sure everything comes in properly after, and the hit is only a 20% LCP, is not that big a hit. I would have expected closer to like a 2x. I don't want to go too deep in the performance characteristics because like my opinion is that everything's like a stone's throw from each other now. And the really cool win with server islands isn't that it's the fastest solution. It's that it's by far the most convenient solution that's fast enough. Yeah. Thank you, Fred, for stopping by the way. The hill that I will die on consistently is that if a meaningful portion of your site is static, you should be able to load that portion as quickly as possible. This is part of why single page apps actually felt decently fast, because you could get something to the user almost immediately and they would see something instantaneously. The more time you have to spend on that shitty blank white loading page with the loading bar on top, the worse the experience is for the user. And if the site itself actually takes a bit more time, but they get something meaningful back earlier, it feels better than if the whole thing comes faster, but you're stuck on that loading page waiting for it for a while. Like if I go back to ping, if I go to my dashboard, that little loading spinner there, even if it took 5 seconds to load the rest of the stuff, Just having that there and feeling like you're getting something feels so much better than the blank page from the browser that you would get instead. So the cool thing with this that I'm pumped every framework is now focused on making happen is that we can get the first response through a CDN. The margin for error between Next solution and Astro solution is just bickering about numbers that I would argue don't matter that much because both feel 10 times faster than not having the first bytes come from a CDN. Let me know what you guys think. I know all these different ways to render stuff on the server is getting a bit confusing. I hope that this can make it a little bit easier to follow. Until next time, peace nerds.